Okay, picking up where we left off, we're on page 182, talking about the V lookup, right? And same thing with H lookup, rather than just going horizontal. There is another option here that we probably need to talk about, and that's towards the end here. You can tell it whether or not you want to have an exact lookup. Okay. Well, this is not going to work for me very much. In fact, I'm going to go ahead and put false, which means exact match. Okay. So I'm going to type that in and hit return, and then I'm going to grab this guy and drag it on down. So only a very few of them are going to light up, right? So the default, believe it or not, is approximate, which in this case is exactly what I wanted. So I'm going to put this back to true, or leave it off, either one. And that means use approximate, which is what I wanted. What I basically wanted is I set up these ranges. So if it was between the range of this and this, it popped in. Okay. So that's how that guy looks. I'm going to skip over. A match is basically kind of the same thing, except it just tells me where I'm at. It tells me which row the match occurred at. Okay. So if I wanted to kind of like do my homemade, let's say I wanted to do a completely clumsy homemade version of VLOOKUP. Instead of having it go and do the translation, it'll just look through here and say, aha, whatever it is you're after is on row 4. Okay, so it just tells you the row it's on. Okay. All right, so take a look at that. So one more time, VLOOKUP. The arguments are, the cell value that you're doing the lookup, which in this case would be like 88.8. The range of values, which is almost always going to be 2 columns, okay, which was this stuff here. And that range of values needs to be anchored. Okay, so I need those dollar signs. The next one is what column inside this selected range is what they answer to. Now, hey, what happens if I go back to here and put this at 1? Well, it's still going to work. It's just going to give me the numbers, okay? I mean, all it did was find where it is in the number and gave me the number. Well, that's kind of dumb. That's not what I wanted. But that is how it works. Okay. And then the last one, of course, is do I want to use approximations? Okay, this next section, it talks about doing payments. And you accounting people kind of sort of know how this works. But you have an equation for doing, you have the loan amount, you have interest, you have the amount of time, and you can solve for the payment. If you had the payment and the number, you could solve for interest. If you had the interest and the number, you could solve for the, for the period. It's all the same calculation, just spun different ways. So I'm going to go to a blank spot here and say, how about my loan amount? And who cares if I misspelled it? And I'm borrowing $4,000. Woohoo! My interest rate. Now, the interest rate is going to be, typically when you talk about interest rates, you're talking about the annual percentage rate, the APR. So let's say I'm doing it, I don't know, this is a contrived example, but I'm going to say 12%. And let's say I'm going to do monthly payments, and so I'm doing 36 months. So this is not the months. 36. So I want to know what my payments are going to be. Okay, so here's how it works. So I'm going to use the payment function, PMT, and then you fill in the balance. So the first one is the rate. Now you got to be careful because I told it I wanted 36 months, but I gave it an annual percentage rate. So I really have to click on this and then divide by 12. Okay? So I'm doing math inside my formula because I don't want the APR. I want the monthly equivalent of the APR. Cool. And then whatever the heck that is. Okay, so the months, what we're after, and how much I'm actually doing here. And ta-da! I owe $132.86. Yay! Cool. And just for the heck of it, let's just do here. Let's take this times the number of months, just for the heck of it. Like, woohoo! So I'm spending 700. Well, hey, come on. I'm not doing math in my head. Dang it. That minus that. Okay. Now, hey, this is one of those good example of where maybe the ABS function would come in pretty doggone cool. I mean, in the accounting world, it is appropriate that the loan amount will show up as a negative number, but it's kind of inconvenient for me. So I'm going to go here and just put ABS. Remember that? ABS to make that an absolute value. Okay, cool. It's just conventions. Doesn't have to be that way. So I'm paying $782.86 in interest. Woohoo! Now there's other ones. There's the PMT one is the one solving for payment. The IPMT is the one solving for interest rate, and the PEPMT was the one that solves for the period. In other words, you know how much you're paying, you know all this stuff, and how many months is that? Okay, it's the same equation, just being spun 3 different ways. On page 186, they talk about logical functions, and you kind of sort of need to know kind of like the truth tables to make any sense of this. So on page 186, they talk about what happens if I compare things. So for example, here I want to know, for example, if this number is bigger than that number. Okay, now I don't want to know what the number is. I just want to know, is it bigger? Okay, this sounds a little weird, huh? So I would do that greater than that. Okay, so the greater than is asking a question. Okay, so unlike on these a lot of others, it's just going to come back and tell me true or false. Okay, so those are logical functions. It is true that 4782 is larger than 4,000. Okay, cool. All right, so you could ask other types of questions. For example, and so greater than or equal to is an example. By the way, whenever you have a greater than or equal to or less than or equal to, the equal is always at the end. Okay, it's never at the beginning of the symbol, so it's always going to be like the greater than equal to or less than equal to. It's never going to be equal than the other operator. Okay, just telling you. It's a good thing to remember that the equal sign always goes on the right hand side. Okay, if it's a compound operator. If you're coming from coming from like a computer language, you may be tempted to do something like that with 2 equal signs, you know, because some computer languages do that. That's not how it works. Only 1 equal sign here. So now that looks a little weird, doesn't it? The first equal sign is just part of the notation for the formula. Then I'm asking a question. So if you were in algebra, you might look at that and go, "What is that? You know, that equals that?" Now this is not like an assignment. I'm not assigning the value of J19 into I16. That's not what I'm doing here. I'm asking a question. Okay, so most people just don't have it produce trues and false. You have it do other things. Okay, so here's an example of, let's go over here someplace. So if you spent more than $10, then I'm going to say you're going to get a discount. So what I want to know is what your discount rate is. Okay, so here we go. So here I don't want to just say this greater than 10, okay? Because that's just going to tell me true. That's not what I want. I want to have a discount rate. Okay. So I'm going to embed that inside an if statement. So I'm going to start with if, okay, open parentheses, and then put in that greater than 10. So if that's greater than 10, the discount rate is going to be, I don't know, 2%. Oh, this is the interesting thing. How do you type a percent inside a formula? Well, I was tempted to do that. Okay, they don't really like that. They really just want plain numbers. So 2% would be 0.02, right? And if it's not greater than 10%, you don't get any discount whatsoever. Okay. So I'm going to grab these guys and make them percents. I'm going to grab this and drag it down. So what it did is it went through and said, if that's greater than 10, then put a 2% here. If it's not, then put a 0. And then, of course, I could have a sum over here someplace where I, subtracted well, I guess I can go ahead and do that. Let me go ahead and just insert something here. And so my new total is going to be that minus that times that. Whoa! Oh, I don't want this to be a percent. Let's make it currency. Okay. Okay, so if you got no discount, then your total came out the same. If you had a little bit of discount, you got 2% added on. All right, that's how an if statement works. Now, if statements can be kind of complex. Let's say, for example, that you have a scenario where you're trying to figure out a discount or whether or not... okay, let's do another one. This example is getting kind of ridiculous. But let's say I have age here. Okay, and so this person is 10 years old. This person is 30 years old. I'll fix that in a second. This person is 70 years old. And this person is 40 years old. Okay, because I inserted it smack dab in the middle there, it was thinking it was helping out. It really wasn't. So now what I want is, I want to know if you're a child or a senior, you get an extra 5%. So how would I do that? Well, the problem here is I could do it the way I did it before. I could go in here and say if, age is less than 12 for a child. But then how do I ask it two questions? How do I ask it, are you less than 12 or are you greater than 62? How do you ask it two questions? Well, that's a little weird. Okay, well, let's just do one at a time. So first one is going to be child. And the second one is going to be senior. All right, so first I want to know if you're a child. So first thing I want to do is say, I'm just going to let I'm going to say this is less than 12. Okay, so all I want is true and false here. Then over here, I go and say, if this is greater than 62. Okay, so now what I want to know is if either one of those is true, then they get a discount. Okay? So the way you combine them together is with an or statement. This is how it works. It's kind of weird. So I would say or, and then that less than 12, comma, that greater than 62, comma. Okay? So I should have two of them when I'm done. So that one is both. This is both. Okay, so if I wanted to do a discount now, based upon that, I would do an if statement, because, again, truths and false don't help me much. So this is the discount again. So how would I do that? Well, I'd do it with an if statement. Now, I'm going to combine all this together in one giant formula. So don't let your eyes roll back in the back of your head. Just follow along in the book. I think you'll be okay. So if, and then I'm going to, instead of doing a if like we did before, here I'm going to say or, that less than 12, comma, that greater than 62, comma, not comma, parentheses. Okay. Now, so that's finished off my or section. And now, if true, you're going to get a 10% discount. If not, you're going to get nothing. Okay. So I'm going to grab that and pull it down. Okay, now let's look at this one more time. This is admittedly a little complex. You have to kind of work on the inside going out. So first thing I have is an or. And the or statement is going to combine two logical things together. The are you a child and are you a senior, combining them together, and then it's going to go to the if statement and figure out whether or not you get a 10% discount or not. Okay, this is a good place to start for the 15-minute mark. We'll finish this off in just a few.